I'm CK. Today we've got a sequencer, the LL8 II from Robaux or Robaux, depending, I don't know how to pronounce it correctly. I apologize for that. And normally I don't have it in my hand when I'm making these intros, but I was going through the video today and my number one camera, this one, had a microphone failure, so for most of the video up until the test section we'll be hearing the audio from my overhead camera, which is a little bit noisier. I apologize for a slight degradation in the quality, but I still wanted to get the video out. So I hope you enjoy the video. Let's open the package up. I don't know if I can just pull it open. Knowing me, I can't. Oh no, it's there. God, use some beefy glue on that. I think I'm going to cut it open just because of the glue they use. Another sticker from my sticker wall. Here's the assembly guide. Looks pretty straightforward. I don't know. Oh, I see. Huh, that's interesting. They want to put stuff together on the panel first. That's not typical, but we'll do that. Oh no, another sticker. 2 stickers. Bag with resistors, diodes, a crystal, 16 megahertz, a couple of caps, transistor or voltage regulator. I can't read the part number. It's a voltage regulator and some LEDs. Here's the user manual to go with it. We'll set that aside because we'll never ever ever read that. And here's the front panel. And we'll just tear the bag apart because that's the way they are. It is a 16-step sequencer, looks like. It's got a whole bunch of jacks. I'm not sure because they only go 1 through 8, so I'm not sure what they're outputting. There's a play button probably and a rotary knob for something. Then we've got something that shows sliders, like it might be for settings. There's a matrix type button there. I don't know what that'll do. That looks like a note with whatever. That may be a transpose. And a floppy disk icon for save. Eventually we will get away from using floppy disk icons for save since nobody uses floppy disks for the last 10 years. Got pin headers, jacks, some standoffs, power connector, all as you would expect. Put that aside for later. Power cable. Here is the button matrix. Interesting, it's in 2 parts, or at least the silicon side that makes the actual contact. Those rings that you see there are the actual conductive material that will make contact. Here is a couple of chips, an ATM Mega microprocessor from Atmel, a something, I'm not sure what that is. Let me slice this one too. It's a DB102. It's a 4-pin. It may be a optocoupler.
I'm not familiar with the logo of the manufacturer either. I'll look that up. And then a 74HC595 from Texas Instrument. I've used that before, but it slips my mind what it does. I'll look at that up too. In here's circuit board. Feels like there are probably two of them in there. Those are precautions for handling electrostatic sensitive devices. So I'm going to assume that means there is surface mount stuff already installed on this. Man, I'm going to go just ripping it apart. I can't figure out how to get it out normally. Okay, we've got a little daughter board, which will go for might go there, but I don't know. And we've got the main board. And that's the little pads that will be under this matrix. So those little black circles will bridge these legs on these pads to make contact. And then we've got another board. These are interesting boards. I like them. They're, of course, through-hole plated. The values appear to all be on the board. Whole bunch of 1K resistors, a couple of 10Ks, a bunch of 100 ohm, and then a bunch of 10K diodes. Crystal will go there. Maybe a couple of caps there, and a 104 cap there. Bunch of diodes. It's Diode City today. And then I believe, there's a MIDI I/O option here, and another connector too. Let's see. I'm seeing if it's got a copyright date on any of these boards, because I don't know how old this is. Not that it matters. So this will go here. This will go up here. So the jacks are inline? Oh yeah, look at that. The jacks are inline. Yeah, they're inline. That makes sense. The jacks will go there. And then this board will go behind it all. Now it's got a DFC3 printed and taped on the back of the board. So, in terms of complexity, it's not very complex. There's a bunch of resistors, but they're mostly, and there's only 1, 2, 3, 4 different values. Oh, and here's a little, looks like a power connector, because that's 12 volt there, 5 volt there, and the center is probably ground. And yeah, this is an optocoupler. Okay. I'll get the soldering iron heated up, and we will get this thing underway. And as I said, we're taking a slightly different approach for most kits. We're going to do some mechanical assembly first. So we get the mechanical bag open and the parts out. And we're going to start by putting the pin header on the back of this jack board. Get some solder. Grab the 20 pin female header. Oops. Don't need a panel nut on it. And it's going to go on this side with the Roblox text on it. Robaux I'm not going to be able to say that. I'm not even going to try. It's insulting for me to try and mangle the language. Now that's all crooked, which is why I only did one pin. So now I'll just heat that up again, flatten it out, and there it goes. Get the rest of these pins. Now we're actually going to put the jacks on this board. Oh, I'm putting it on the wrong side. I'm looking at it saying, it's not going on right. That's because I was putting them on the wrong side, because I'm an idiot. And now, already, it's so interesting to do this at the very beginning of the build. We're going to put the panel on, drop one panel nut on it. I'm going to solder one of the legs of the jack I just put the panel nut on. So now everything's secure, it's not going anywhere. And I will go ahead, I'm going to put something under this so the jacks aren't being pressed out away from the board. Now I'll solder all the rest of these connections. Let me make sure I got them all correct. They all look good. Okay, now we'll put the rest of the panel nuts on. So that's that. Easy enough. Now we're going to put the LEDs, and they're going to go behind the buttons. So, and I keep saying LLS, I believe it's LL8. And now that we have this board installed, this play button is not a play button, it'll be a trigger to start and stop, I assume. And this curly is probably CV, or it could be just pulses to set the speed. Again, I'm still just assuming that. I don't know for sure. So we're going to do the LEDs. Let me get another parts bin. Take out one LED first. See what color these guys are. Using my multimeter. Give it a little current. And they're blue. I mean, they're white. They're white. No phosphor coating, so they are stark white. Very, very blue. Now let me see. Okay, good. LEDs go in the center of each button, and it's easy to see. They're very clear, plus and minus, as well as a diode schematic symbol, so it will not be difficult to understand what the polarities are. So we'll put all these on. And it feels like I'm going to get this done in one take. I'm not going to get it done in one take, but it feels like it. I mean in one segment. Even though you don't know how many segments there are in any of them, because when I stop the camera and take a break, you don't know it. Now I'm going to want to get all these very flat on the board. Now it's interesting, it does look like it's got a little phosphor on the LED, top of the LED or under the LED lens, but from the side at least it sure looked very, very acidic blue, white. Now one thing I can do to double check the polarity, all the long legs should be up. I mean facing that way, that's what I meant by up. Now I'm going to want these LEDs very flat on the board. So what I'm going to do is I'm going to solder one leg of each and then go through, flatten them to the board, then solder the other leg. I'll demonstrate after I get one leg of all of them soldered. They're in pretty good shape, but some of them are a little cattywampus. So I will just press on each one and heat the solder just to make sure they're completely flat. They are all lined up. So I'll get all the other pins. Just double check I got all of them and they're all good. These are a little, there we go. Had a little bit of solder overflow. Now do the pin headers on this one. And they're going to go back here, and they're 15 pin females. And there are those pin headers. Now we're going to mount the buttons on here. Pull it out of the bag. Now there are holes here that we're going to be putting standoffs through, and that guides us as to how the buttons go on, because I don't think it'll go the other way with the standoff holes lined up. Oh, it actually will. Huh, interesting. So the question is, okay, so you can tell because if you look at the picture, if you want to make sure you get it right, if you look at the picture, this short area above the pin header pins is where the major block goes, and the four bottom ones are where that one goes. And it looks like this bracket is 3D printed. And again, I think it may not matter. Oh yeah, it does matter, because that is where the screws are going to go. Okay, so yeah. The short ones with the threaded shaft go through like so. And then, oops, and they fall out when you turn it over. Take that screw back out so I don't forget. Probably could have put the spacers. Why don't I do that? You don't really need to have the buttons in place to put these standoffs on. So if anybody from Robaux ever sees this, switch that step and put the standoffs on before you put the button array on, the button matrix on. Much easier to tighten these up if you do that. Then we can go back and get it all lined up. There we go. So the keypad is on, and of course, because it's associated with my household, it's got cat hair all over it. Now we'll put the frame on. Oh, huh. They were separate. Whatever. Even though, no, it didn't show it that way. Now we put the front panel on, like so, and we use the black screws, which are Allen head screws. I don't know if I have an Allen wrench to fit these on the workbench. These fit? Yes, it will. So I am prepared. I didn't plan to be prepared, but I am prepared. Snug these down. I'm not going to make them too tight, but just a little bit more than finger tight. Like a quarter turn more than finger tight is probably going to be good for this. Maybe half turn. And that's it for the front panel. I'm checking to make sure all the buttons work and don't bind in any way. Seem to be fine. Now we're going to go to the main board. And we got 32 diodes to put on here. And as you can see, there's a good heavy white line showing where the cathode side of the diode needs to go. Let me get all those diodes out. They're the 4148s, I believe. Let's put one on to see how they fit. How far we have to bend the leads in to get them the holes right. Not quite all the way up against the body, but pretty close. So I'm going to do all the rest of these with no commentary and fast playback. All the diodes are on, and as you can see, the stripes should all be on the same side on each line. They're facing each other. So if you got one right, you can see you got all of them right. Of course, if you got the first one wrong, then you got it all backwards. But we're going to assume you got the first one right. Now we're going to do some 100 ohm resistors. And as you can see, he's politely written the resistance value on the paper tape. With all the resistors on, time to do a lot more of the other little bits and pieces. First we'll put the 16 megahertz timing crystal on the board. Timing crystals are not polarized. Then these two 220 caps. Okay, now we're going to do two pin headers. One of them is for, these are both pin headers I'm not going to use, but this one needs to go on there because it has a jumper on it. So I will put this one on, but I'm not going to put the other one on because I'm never going to use it. Yeah, okay. The 595 is a shift register, chip. So we've got that one pin header on. Now we're going to put the jumper on. It tells the thing how the programming port should be used for MIDI or interface for firmware updates, and I'm just going to put it here because I'm going to do neither of those things. But we do want to complete the circuit. And then this chip, which I keep thinking is an optocoupler, is not an optocoupler. It's a rectifier. I'm not sure. I'm going to have to look up the schematic for this if I can find it, because I'm not sure what it's rectifying. Because you normally don't find a rectifier on a eurorack board, since eurorack is fed by DC. But we'll put that little guy on there. Could be rectifying one of the input lines. I'll take a look once we get it all done. Now, sockets. Make sure the notch is in the right place. Flip the board over. Hold the socket on the board with my pinky finger. Do one leg. Let it cool. Take a look. It is flat all the way along. Do the same for the other IC socket. Yep. That's up. So reheat that, and there, I think you probably heard it click in. Now we'll get to all these pins. We'll put the voltage regulator on the board. Where does it go? Oh. It's bizarre. It goes here. And there's not a standard voltage regulator symbol. You want to make sure that, so it goes right here and converts 12 volts to 5 volts. And there's not a regular symbol, so you have to make sure the flat side is facing up per the build document. That is probably the only reason why you actually need the build document. I don't know why these aren't, why this one's not taken. So there we go. Now the caps, the electrolytics that is. I think they're both the same. Let me double check. I have to see them eye to eye. Yes. And the board is very clearly marked as to their polarity. Now a power socket, which is going to go on the front of the board here. Actually, let me trim these leads. I'll do the pin headers, and I'm going to do it the way they do it, which is putting them in the female headers and then attaching the board. I usually don't do it that way, but that's the way they've got it on this one, so I'll go ahead and do that. And let's double check the orientation. Yep, we're going to put them on like this. Now we'll solder all these down. Take our little screws and screw everything together. And we've got this little jumper which I'll put on here. I don't really care where it goes, but I think we do want to have it on somewhere. Okay, so there we are. It's the front, it's the side, it's the back, other side, top, and bottom. Now we'll put it in the rack and see how it works.
Now let's give this thing a try. Now you notice I didn't put it in the rack. I did actually try it in my standard rack, but the buttons take a good bit of pushing, and my test rack out here in the workshop is not set up for somebody to push that hard on it. Oop, got it running already. So I've got my long cables from the workshop to my, workbench to my audio cart. So that's what I'm using instead. So we're using a frequency central seismograph bass drum thing, and I'm using the LFO to send clock. We can change the drum sound, of course. So let's go through it step by step. This is not a hard unit to operate, but you do have to spend some time learning what it does. Once you learn what it does, you can be very successful with it and use it on the fly. But when you first look at it, it's a little bit not necessarily what you might expect, or it's just more than you might expect. So this is the clock in. This is all the top row are all the sequences. That's sequence 1. That's sequence 2. I'm going to speed it up a little bit. Sequence 4. 3, sequence 4, and so on. So we'll go back to 1. And now we'll go into the different modes. The first mode I'm going to go into is edit. So edit mode, and I'm going to press button 13, and then we're going to press track 1. And now we're on track 1, and it's running the sequence. Oops. As you can see, it's a full 16-step sequence, and I can change it quickly by simply adding, taking out. Now I can hit edit again and go to sequence 2. We'll hit the 4. So that's what edit does. And then random does this. So I'm going to randomize track 2, sequence 2. So I hit edit, hit 15, hit 2, and you'll see the pattern changed. Edit, 15 2, edit 15 2, fifteen 2, I think I may have pegged this a bit shy. Now we'll go to edit 2 and you can see the way the pattern lays out now. And then edit 15 2, changed it, and then I'll go edit 2 and you can see what it changed it to. Edit 15 2, edit 2, and you can see the pattern is different. And you can do that multiple times to get a pattern that you might find very pleasing. I'm going to change the drum setting just because. So that's, and then if we do edit 14 1, and I'm going to go back to 1. The other thing you may notice is it always ends a sequence before it moves on. And you can change that. It tells you how to change it. You can delete tracks. I'm not going to do that. So button 9. See, right now sequence 1 is just going 8 steps. So we go to edit 9 12, and it didn't do what I expected it to do. Okay, now it's going all 16 steps. Okay, let me do that again. Edit 9 12. Again, I don't think I'm getting that right. Edit 9 12. No, I'm not getting that right. Something, again, it's a little confusing to me. But you can see how setting that works. And then you can reset the track lengths. And what else can you do? Oh, you can coin things. I mean, chain things and so on. I'm not actually going to do much more of this. There's mutes and fills. Let's see. What we're going to do for a fill, we're going to press and hold. That didn't seem to do anything. Press and hold the slider key for pattern fill function. It allows you to play selected step repeatedly when you simultaneously press and hold one or more of the step buttons. I may be on the wrong track. I don't know. Yeah, I was supposed to be on track 2. See, now that cuts it out. So if I want to fill, if I want to speed the So you can do fills that way. Let me slow this down a little bit again. And then switches 1 to 8, you can press this button, then mute 1, Now 1, finish its sequence. Well, I'm in 2. I'm sorry. Now 2 is muted. Press it again and press 2, and it comes back. So let me go back into 1 here. Go to edit again, edit 1. Speed this up a little bit. So it's a good studio sequencer, and once you get the hang of the buttons and have a nice firm foundation to press against, your rack needs to be really tight, because it takes a good bit of effort to press these buttons. So I'm going to do some random again. Okay, that changed it quite a bit. Oh, I'm sorry, I'm supposed to be in edit. Lost my head. Edit 15.1 and C1 again. See, it spared that out quite a bit. Edit 15.1. Let's go back and look at 1 again. That changed it a little bit. Edit 15.1. And you can see what it changed there. And you can then go ahead and do whatever you want. So you can plug into all 8 of the sequences, and there's a reset to set you back to the beginning of whatever sequence you're working on. And again, there's save here, so you can save certain parameters to non-volatile RAM. There's a lot to this, and it's mainly about learning what the sequence of button presses you have to go through to get it to actually do what you think it's supposed to do. But it's well worth it. This is a good little unit. Just takes a little time to get the hang of it. And as you saw, it's not too complicated to build, but it works pretty well. So that's the LL8 II from Robaux, and I hope you enjoyed the video.